Dear students, let us start Standard 9 Chemistry ICSE syllabus Chapter 4 Chemical Bonding. In this video, we will be discussing about covalent bond. Okay, covalent bond. Okay, so let us start today's session. Children, in the previous video, we had discussed about electrovalent bond and formation of some electrovalent compounds like sodium chloride, calcium oxide and magnesium chloride. Okay, in this video, our objective is to cover the following topics, that is covalent bond, covalent compound, covalency and formation of some covalent molecules. Okay, so children, we know very well that electrovalent bonds are formed due to transfer of electrons, right? Transfer of electrons. Then what about covalent bonding? So in order to understand this, let us see this example. Here a serious conversation is taking place between hydrogen atom and chlorine atom. Now let us see what they are discussing. Hydrogen atom is saying that I can't get an electron from you, neither can I give you one. Then chlorine atom is saying that no problem, let's just share. So this is what your covalent bond. Covalent bond is nothing but mutual sharing of electrons. Covalent bond is formed due to mutual sharing of electrons. And covalent bond mainly takes place between the atoms of non-metallic elements. Okay. So what do you mean by covalency? Covalency is nothing but the number of electron pairs which an atom shares with one or more atoms. Okay. The number of electron pairs which an atom shares. For what purpose the sharing takes place, children? In order to achieve stable electronic configuration. Okay. So the number of electron pairs which an atom shares is known as covalency. Okay. So now let us learn the formation of covalent compound, that is HCl. Okay. So let us draw the structure. Okay. So this is the orbital structure. This is H. Okay, this is, we know very well that in hydrogen one electron is present in the outermost shell. Okay, this is chlorine, right? How many electrons are present in the outermost shell of chlorine, children? 7, right? 7. So this is 7. So we know very well that as it is decided by H atom and chlorine atom, they will share the electrons. So sharing takes place and they are forming HCl molecule. Okay, HCl molecule. So the molecule is like this. Okay, this one, and this is your nucleus of H. This is the nucleus of Cl, and of course the other electrons which are present in the outermost shell of chlorine. We need to show that. Okay, so this is your HCl molecule. Okay, so next one is formation of covalent compound. What do you mean by covalent compound, children? The covalent compound is formed due to mutual sharing of electrons between the given pair of atoms, thereby forming a covalent bond. Okay, so the covalent compound is formed due to mutual sharing of electrons, and hence they form what type of bond, children? Covalent bond between the atoms. And what type of elements, children? Non-metallic elements, right? So what do you mean by mutual sharing of electrons? In case of mutual sharing of electrons, each bonding atom needs to contribute the electron. Okay, so depending on the number of electrons pair shared, we are having single covalent bond, double covalent bond and triple covalent bond. Okay, so let us see more about single, double and triple covalent bond. Okay, let us learn more. So here you are having your covalent bonding. We know very well that formation of covalent compound involves sharing of electron pairs. Okay, based on the sharing of electron pairs, we can decide that we are getting single or double or triple covalent bond. Okay, so sharing of one pair of electron forms single covalent bond, sharing of two pairs of electrons form double covalent bond, and sharing of three pairs of electrons forms triple covalent bond. Here you can see very clearly this is single covalent bond, sharing of one pair of electron. This is double covalent bond in case of oxygen. Okay, so this is double bond, and here in case of nitrogen we are getting sharing of 3 pairs of electrons. So this is triple covalent bond. Okay. Now let us learn some general characteristics of covalent compounds. Children, tell me what are the characteristics of covalent compounds? In case of covalent compounds, electrons are shared. In case of electrovalent compounds, electrons are transferred. But in case of covalent compounds, electrons are shared. Here, the covalent bond is taking place between non-metallic elements. They have low melting and boiling point. Normally, they can be solid, liquid or gases at room temperature. They do not conduct electricity. Yes, whereas electrovalent compound, they conduct electricity. And normally they do not dissolve in water, okay, but they dissolve in non-polar solvents. Okay, so here you can see a comparison, a table showing the comparison between electrovalent and covalent compounds based on certain properties. Okay, so here you are having some properties like types of elements involved. Children, in case of electrovalent compounds, we are having metals and non-metals. In case of covalent compounds, we are having 2 non-metals only. What happened to electrons in case of electrovalent compounds? Here electrons are transferred, whereas here electrons are shared. What type of bond that forms in case of electrovalent compound, children? Here we are getting ionic bond or electrovalent bond. Here we are getting covalent bond. What is the state of this at room temperature? They means electrovalent compounds are solid at room temperature and covalent compounds are solid, liquid or gas at room temperature. What happens to the, what can you say about the solubility in water? Electrovalent compounds are soluble in water, whereas covalent compounds are insoluble in water. What about the conductivity in solution? Electrovalent compounds are good conductor, whereas covalent compounds are bad conductor. Okay, like this we can compare the electrovalent and covalent compounds. Okay, so let us continue the session with the formation of covalent molecules. Formation of covalent compounds. Children, here also we are going to draw the atomic orbit structure and electron dot structure. Okay, so let us learn the formation of hydrogen molecule. Okay, so here in case of formation of hydrogen molecule, you need to take 2 hydrogen atoms. Yes, 2 hydrogen atom. Okay, so this is your nucleus, this is your first hydrogen atom, and here also H, this is your second hydrogen atom. Okay, you know very well that 1 electron is present in the outermost shell of hydrogen. Yes, so here also you see 1 electron is present. So in order to here in this case they are unstable because they don't have duplet rule or octet rule, right? So in order to attain the stable electronic configuration, what they need to do, children, they should have at least 2 electrons in their outermost shell. Okay, so here what they are going to do, they are going to share the electrons, right? Share the electrons, because we are learning covalent bond, and covalent bond is formed by sharing of electrons. It is not formed by transferring of electrons. Yes, so after combination, what we will get, children? We will get hydrogen molecule. The hydrogen molecule is like this. Yes, like this. So this is your H, this is your H. Okay, so here you can see very clearly that one shared pair of electrons. Here you can see one shared pair of electrons. So what type of covalent bond they will form, children? They will form single covalent bond. Okay, here we are going to get single covalent bond like this, H, H. So it will form H2. They will form single covalent bond because single covalent bond is formed by sharing one pair of electrons. So let us draw the electron dot structure. So this is your hydrogen. As I told you, in electron dot structure we are representing electrons in the form of dot. Yes, so here hydrogen, another hydrogen here, and as I told you, we will have the covalent bond between this shared pair of electrons. So after that, what happens, children? So it will form like this. Okay, or H, H. So it will form H2. This is hydrogen molecule. Okay, now let us learn the formation of chlorine molecule. Okay, similarly, let us draw the atomic orbit structure of chlorine molecule. So this is your Cl, nucleus of Cl. As I told you, nucleus you need to draw. you should not start drawing the shells directly. First you need to draw the nucleus, after that you can start from K shell. Okay, so this is your chlorine. How many electrons are present in the outermost shell of chlorine, children? 7, right? 7. And you know this is chlorine atom and this is unstable, because in order to attain the stable electronic configuration, chlorine needs one more electron, right? So we are learning chlorine molecule, so here also we are going to take 2 chlorine atoms. Yes, so this is your chlorine. As I told you, we are having 7 electrons in the outermost shell of chlorine, so we are going to have the bonding between these two. Yes, so after combination we will get like this. Yes, like this. So here we are having, okay, so this is chlorine, this is chlorine. Okay, children, here you need to show, since you know very well that here we are bonding is taking place between one shared pair of electrons, but you need to show other electrons also which are present in the outermost shell. Okay, so this is other electrons which are present in the outermost shell. So this is your chlorine molecule. Okay, now let us so we are getting here Cl2. Okay, Cl, so we are getting Cl2. Now let us draw the electron dot structure of chlorine molecule. Okay, so this is your chlorine. We know that how many electrons are present in the chlorine, children? Outermost shell, 7 electrons. Here also you see 7 electrons. Okay, so bonding will take place between these two pair of electrons. Okay, this pair of electrons, this one and this one. So after this we will get chlorine like this, and this one will be represented in this form. Okay, because this is a shared pair of electron. Okay, so like this we are doing we can draw the electron dot structure of chlorine molecule. Okay, now let us draw the formation of oxygen molecule. Children, here also we will draw the atomic orbit structure of oxygen. Children, we know very well that how many electrons are present in the outermost shell of oxygen, children? You know very well that 6, right? We are having 6. So here you see 1, 2, 3, 4, 5, 6. Yes, plus here also oxygen 6. So 1, 2, 3, 4, 5, 6. Why I am showing like this? You know, it will become very easy in order to show the bonding, okay, between the electron. That's why I have shown the electrons in this way. Okay, so this is the case before combination, right? So after combination, what will happen, children? Like that hydrogen and chlorine only, they will form the oxygen molecule, right? They will share, because you know that they are having 6 oxygen atom is having 6 electrons in the outermost shell. They need 2 more electrons to attain the stable electronic configuration, right? So here we are going to get 2, here you will see that the sharing will takes place between 2 pairs of electron. Here you are going to see double bond, because here 2 pairs of electrons you will see after the combination. Yes, bonding will takes place between 2 pairs of electrons. You see here how we are drawing the orbital structure. This is your, yes, so this is your oxygen, right? O. This is your oxygen, right? O. So here also you see this 2, here 2, and here also 2. Okay, so here you can see that 2 pairs of electrons are shared. This is oxygen atom, this is oxygen atom, and this is oxygen molecule, right? So here 2 pairs of electrons are shared, so they will form definitely single or double covalent bond, children? Double covalent bond. Okay, they will form double covalent bond. Okay, now let us draw the electron dot structure. See, children, as I told you, we need to show the outermost electrons in the form of dot. So this is like this, and here also 1, 2, 3, 4, 5, 6. Okay, these 2 are oxygen atom, and after combination we are getting the bond like this, 1, 2, 3, 4. So here you can see very clearly 2 pairs of electron are shared between these 2 oxygen atoms in order to attain the stable electronic configuration. Okay, Okay, so this is your oxygen molecule. So here, as I told you, double bond, so it will form O2. This is your oxygen molecule. Next one is your formation of nitrogen molecule. So let us draw the atomic orbit structure first. Okay, so we know that children, tell me how many electrons are present in the outermost shell of nitrogen atom, children? Yes, this, yes, 5 electrons. Yes, 5 electrons are present in the outermost shell of nitrogen. So this is 1, this is 2, and here 3. Okay, so 5. So how many electrons nitrogen needs to attain the stable electronic configuration, children? Since it has 5 electrons in the outermost shell, it needs 3 electrons in order to attain the stable electronic configuration. So here we are going to see the sharing of 3 pairs of electrons. Hence I have written like this. Okay, 3. So this is your nitrogen atom. So again I am going to take one more. This is your nitrogen 1, 2, 1, 2, 3. So first this one, okay, and another one, okay, and here one. So here we are going to see the sharing of 3 pairs of electrons. So here we are going to see which type of bond, children, tell me whether we'll get single bond, double bond, or triple bond. Of course, triple bond. Okay, so you see here, so this is nitrogen, here also nitrogen, and here we are going to see the sharing of 3 pairs of electrons like this. Of course we need to show other 2 electrons are also which are present in the outermost shell. Let us draw the electron dot structure. Okay, so here as I told you consists of 5 electrons in the outermost shell. So it needs 3 more electrons to attain the stable electronic configuration. So like this we need to show. Okay, so after that, after combination, what will happen, children? Yes, this will form like this. Okay, and this pairing will sharing will takes place, sharing of electrons will takes place between these 3 electrons. Okay, these 3 pairs of electrons, sorry, these 3 pairs of electrons of the nitrogen atoms. Okay, so you can write like this. Okay, so you can write like this. So what will happen, children? After that we will get N triple bond N. That means we will get N2. Okay, we will get N2. This is nitrogen molecule. Okay, now let us learn the formation of water molecule. Formation of water molecule. Tell me, children, how many electrons are present in the outermost shell of hydrogen atom? 1. Yes, so let us draw the 1 electron. Similarly, tell me how many electrons are present in the outermost shell of oxygen atom? You know very well, 6. 6. So here 1, here 1. Why I am showing like this? In order so that sharing, we can show it properly. Sharing of electrons or sharing of electrons between the atoms can be shown properly, okay, or clearly. Okay, here also see 1 electron. Okay, this is, so we are learning the formation of water molecule, and you know very well the formula is H2O. That means 2 hydrogen atom we need to take and 1 oxygen atom. So we have taken like that only. Okay, so now after combination what will happen? After combination we are getting water molecule. So here you can see very well, this one will be, since hydrogen need 1 electron in order to attain the stable electronic configuration. So here the bonding will takes place like this, and here the bonding will takes place. Okay, so here as we know that we will get single or double bond, children, tell me. We will get single bond. Okay, single bond. And of course we need to show other electrons which are present in the outermost shell of oxygen. Okay, oxygen atom. So what we call to this, children, this pair of electrons and this pair of electron, we call it lone pair of electron. Lone pair of electrons. Children, it is very important to mention here that it is lone pair of electrons. Lone pair of electrons. Okay. Now let us draw the electron dot structure. Here what happens, children, in case of H2O, normally we are representing the electrons in the form of dot, but here we are taking 2 different atoms, okay, like hydrogen and oxygen. So in one case we will put dot, and in another case we will take cross. Okay, it will become very easy for us to understand. Okay, so this is your hydrogen. We can take it cross for hydrogen. It's your wish, children. You can take a dot for hydrogen and cross for oxygen also, no problem in that. Okay, so one electron is present in the outermost shell of hydrogen. So I have denoted that one atom, one electron of hydrogen atom in the form of cross. Okay, so this is the one electron which is present in the outermost shell of hydrogen atom. Then oxygen, how many electrons are present, children? We are having 6 electrons present in the outermost shell. Okay, then again hydrogen atom, we will take it cross. One electron is present in the outermost shell of hydrogen atom. So this is your hydrogen atom, this is your oxygen atom, this is your hydrogen atom. So after combination, what they will form, children? So the bonding will be like this. Okay, H, one cross of hydrogen and dot of oxygen, and then O, this 2 we need to show. Okay, and again one cross and dot. Okay, so this is your hydrogen molecule. This is your water molecule. This is your water molecule. Okay, so here how many bonds you are seeing? That here single bond is formed, here one single bond is formed. So here you can say that here we are getting 2 single covalent bond, right? Here we are getting 2 single covalent bond. Children, if it is asked to draw the electron dot structure, you need to draw electron dot structure, or if it is asked to draw the atomic orbit structure, you need to draw atomic orbit structure only. Now let us learn the formation of carbon tetrachloride. Okay, carbon tetrachloride formula is CCl4. Okay, that means we are taking one carbon atom and 4 chlorine atoms, right? 4 chlorine atoms. So now tell me, children, how many electrons are present in the outermost shell of chlorine atom? Yes, how many electrons are present? 7, right? 7 electrons are present. Here also 7. 1, 2, 3, 4, 5, 6, 7. Here also 7. 1, 2, 3, 4, 5, 6, 7. And here also 7. Okay. Yes. And now tell me, children, how many electrons are present in the outermost shell of carbon atom? 4, right? 1, 2, 3, 4. Here it is not advisable to take cross, and okay, because here we are doing atomic orbit structure, so no need to take cross. Okay, why I am telling that? Here also we have taken 2 different atoms, chlorine and carbon. So here we are not, it's not advisable to take cross for one atom and dot for another one. It's simply we are using in case of electron dot structure. Okay, so now you see this I am showing you before combination. Okay, so here plus 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 mean they all will combine. So here we are going to see bond between these 2. Yes, this 2, this 2, we will see bond, because carbon 4, in case of carbon atom 4 electrons are present. Yes, another 4 electrons carbon need to attain the stable electronic configuration, and in case of chlorine 7 electrons are present in the outermost shell. Chlorine atom needs one more electron in order to attain the stable electronic configuration. Okay, so here you can see the sharing of one pair of electrons, but how many bonds you will get? Here we are going to get 4 single covalent bonds. See between these 2, one single covalent bond, here one single, 1 and 1. So we are going to get 4 single covalent bond, but between chlorine and carbon, here you will see the sharing of one pair of electrons. Okay, so after combination it will become like this. Here 2, here also 2, because sharing takes place between these 2. Here also 2, and of course other electrons which are present in the outermost shell of chlorine, you need to show that. Children, one thing I'll tell you here, if you are forgetting to show the other electrons which are present in the outermost shell of chlorine and you are showing only the sharing part, then you will lose marks. So it is always advisable to show the other electrons which are present in the outermost shell of chlorine. Okay. Okay, so here, so like this we are getting CCl4. carbon tetrachloride molecule. Now let us draw the electron dot structure. As I told you, here we are taking chlorine atom and carbon atom. So here in one case you can take the dot, and another case you can use cross in order to show the electrons which are present in the outermost shell of the atoms. Okay, so this is your chlorine. How many electrons are present in the outermost shell, children? We know very well that 6. So we are taking dot for chlorine. Okay, it's your wish, children, you can take cross also. Okay, no problem. And we are taking cross for carbon, right? So again chlorine 1 2 3 4 5 6 7. Here also chlorine 1 2 3 4 5 6 7, and here also chlorine 1 2 3 4 5 6 7. Okay, so here you can write plus. Plus shows that they are this is the case before combination. Okay, so after combination what will happen, children? You will see the bonding between these two, bonding between these two. Okay, bonding between these two, yes, and these two electrons. Okay, so we will get chlorine cross. Okay, similarly here also, yes, similarly here also and here also. But if you are not showing other electrons which are present in the outermost shell of chlorine, as I told you, you will lose mark, children. So like this you need to show. Okay, so yes, so this is 6 electrons which are present in the outermost shell. Okay, so it will form like this, C in the middle, then Cl, bond will form between here also Cl, here also Cl, and here also Cl. So we are getting CCl4. How many bonds we got, children, in this case? This is 1, this is 2, this is 3, this is 4. So we are getting 4 single covalent bonds. Here we are getting 4 single covalent bonds. Okay. Now let us learn the formation of ammonia molecule. What is the formula of ammonia, children? NH3. That means we are taking 3 hydrogen atoms and 1 nitrogen atom. So let us draw the atomic orbital structure first. Okay, so here you can see 3 hydrogen atoms and 1 nitrogen atom. So we know very well that 1 electron is present in the outermost shell of hydrogen. So like this we can draw. And how many electrons are present in the outermost shell of nitrogen, children? 5. 5 electrons are present. So here 1, here 1, here 1, and 2 here. Why I am showing like this? Sharing of electrons. It will become easy to show the sharing of electrons between the atoms. Okay, so here you can see clearly this, here this sharing will take place like this, here like this, and here like this. Okay, so after combination, mean this is the case, so we will get here single bond, right? So like this, here also single bond like this, here also single bond, so like this, and of course you need to show this 2 electrons also which are not taking part in this reaction but they are present in the outermost shell. Okay, so what we call to this? We are calling this a lone pair of electrons. We are calling this lone pair of electrons, and you need to mention this when you are drawing orbital structure or electron dot structure. Okay, now let us draw the electron dot structure. So in electron dot structure, as I told you, we'll take one cross for one atom and dot for another atom. Okay, so here hydrogen. Okay, so this is your nitrogen in the middle and hydrogen here. Okay, so 1 electron, here also 1 electron, and here also 1 electron. So for this nitrogen we will take cross, right? Cross. Okay, 5 are present. So we can write plus. Plus shows that they will combine. Till now they have not combined. Now this is the case of before combination, right? So here you can see. So no need to mention this. No need to draw this. Okay. So simply you can write before, after combination it will become like this. Okay, so here also like this, here also like this, yes, and of course this is the cross. This is the lone pair of electrons. Yes, lone pair of electrons. Okay, So like this we are getting how many bonds, children? Here one and here one. We are getting 3 bonds, right? We are getting 3 bonds. So you can write 3 single covalent bond. We are getting here 3 single covalent bonds. Okay, here we are getting 3 single covalent bonds. Okay, so here we are getting the bond like this, H, 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 and we will get NH3. Okay, this is ammonia molecule. Okay, now let us learn about the formation of methane molecule. The formula is CH4. That means we are taking 4 hydrogen atoms and 1 carbon atom. Okay, so here also simply we can mark 1 electron, here 1 electron, here 1 electron and 1 electron. Okay, and in case of carbon, children, how many electrons are present? We know that in case of carbon we are having 4 electrons in the outermost shell of carbon atom. So like this we can, so bonding will take place between these two, yes. Okay, so in case of orbital structure you can show like this in dotted line, but I'll suggest you in case of electron dot structure, no need to show that between these two bonding will take place. Okay, no need to show like that. So after combination, here you can see the bonding will take place between this pair of electron. So you can write like this. Okay, so like this we are getting CH4. Okay, let us draw the electron dot structure. Electron dot also you see H, 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 H. So we are writing C. Okay, we are writing C and we are taking cross for C. So 1, 2, 3, 4. So this is your 1, 2, 3, 4. Okay, so after that what will get, children? We will get H, H, and this is dot, this is cross, again H, again this one H, and again this one H. Okay, so like this we are getting CH, H, H, H. So how many bonds we are getting here? 1, 2, 3, 4. 4 single covalent bonds. So this is your CH4 molecule, that is methane molecule. Okay.